Casey McCormack's a wildlife technician. He's with the Idaho Department of Fish and Game, and he's also a master's student in environmental science at the University of Idaho. And he's worked on a lot of wildlife and monitoring projects in the northwestern US and Alberta, but he's become really interested in climate adaptation efforts for wildlife and ecosystems. And this topic came up by Michael Lucid at the Creston Valley Conservation Action Forum. So people are really interested in learning more about these microhabitat restoration techniques. So we're very thankful that Casey could be here remotely from the US.
Hi, like Juliet said, my name is Casey McCormack. I'm with Idaho Department of Fish and Game and also a student down at University of Idaho at the moment. I'm going to go talk about some of these microhabitat restoration techniques we're trying down in Idaho. So this was part of a bigger project called Bees to Bears that Michael Lucid probably talked about before, and this involved restoring 100 hectares of forested lowland habitat in the Boundary Smith Creek Wildlife Management Area, and that's actually literally right on the border, about 12 kilometers south of Creston, so pretty close to home for you guys. And the goal was to improve the landscape climate resiliency of 6 species of greatest conservation need. And that was done through restoring of ephemeral ponds and stream beds, reforestation of the valley bottom through planting of 50,000 native trees and understory plants, and also what I'll be focusing on today, which is the creating of topographically altered habitat to provide cool air refugia. So just to clarify, I'm a student and I've been fortunate to help, but I'm certainly not the one who made it happen. This was a partnership with the Idaho Department of Fish and Game and the Yellowstone to Yukon Conservation Initiative, kind of headed by Michael Lucid, Jesse Grossman, and quite a few other folks, and is funded through grants from the U.S. Fish and Wildlife Service, Wildlife Conservation Society, Climate Adaptation Fund, and the Doris Duke Charitable Foundation. And there's been lots of folks from lots of people from Yellowstone to Yukon, IDFG, and also a lot of citizen science volunteers collecting native seeds and other folks as well. So just want to give a shout out to them. Like I mentioned, the idea for these structures were to reduce temperature, increase moisture for gastropods, amphibians, and insects, specifically pale jumping slugs, western toads, northern leopard frogs, western bumblebees, and Suckley's cuckoo bumblebees. Those are at least the species that were identified in our Idaho State Wildlife Action Plan, but hopefully many other species may benefit from them as well. These are the structures, just kind of a layout. If you can envision, these are kind of ridges and troughs, and south would be to your right in this picture. So the idea is that these structures will kind of block the sun, at least during portions of the year. So we'll get a little bit better look here in a second. And these were designed by Brian Heck of Ducks Unlimited. Here's kind of an aerial view of these right after they were built. Just kind of give you a real life idea of what they're like. So we constructed 13 of these total across the management area, 3 of which are controls, which are just kind of flattened areas that we can do some monitoring on as well and kind of compare their microclimate to that of the actual built structures. And the total acreage is about 6.5 hectares for the whole project for just the cars being built. For the structure, these range are about 10 to 15 meters between ridges or troughs, however you want to look at it, and they're about 1.5 to 3 meters deep, depending on the car. And each one is about a half hectare in size, to kind of give you an idea. Here's kind of a model built from a DEM here to kind of help you visualize it. And so south would be your right in this photo, and you can kind of envision with the shadowing on this how these structures may help to reduce solar radiation. And also, we're hoping that it could actually have a cool air cooling effect. With these ridges can kind of create micro inversions, you could say. These are obviously going to be kind of a small factor, but it could help. And there's also been some microclimate research done that's been showing that like wind and eddy effects can be altered by just small structures on an open landscape like this. So precipitation and wind may move differently over these and actually help trap moisture and cool air as well, in theory, but we'll see how that goes. So what I've been doing is monitoring to see how well these actually reduce air temperatures, reduce the temperature near the soil surface, retain soil moisture, reduce solar intensity, and then possibly allow for cool air cooling or inversions. This is just kind of a visual exercise. We did this last fall with an industrial smoke bomb, you could say. So on the left was soon after the emitter was lit, and about after 30 minutes, you can kind of see how the smoke just settled into these troughs. It's kind of hard to see in these photos, but it did really settle in there, and it sat there for the hour or so we were there. And so I think it helped kind of envision how not only solar radiation might be impacted by these, but they actually might alter and allow for like cool air and moisture to actually build up in these structures. But more specifically, the monitoring I've been doing, I've been concentrating on those 3 that were pictured out of the 13 that were built. They're all kind of close in the same area, and they kind of serve as like a good study area. So focusing on just 3 of 13, or 4 of, I should say, of 13 across the whole project. For temperature monitoring, I've been doing some small temperature loggers, 1 in each linear, or not 1 in each, but 1 in a linear car, 1 in a curvilinear car, and 1 in a control car. And these are essentially buried 5 centimeters below the surface. And the idea here is to kind of capture what the near surface conditions are like. To actually have these monitors above the surface is actually really challenging to get accurate temperature measurements, because solar radiation allows for really high spikes in temperature and aren't really actually an accurate way to monitor what the conditions are actually like. So they're buried there, and they should hopefully kind of emulate what these species of these target species will hopefully be, experiencing in these cars. So yeah, these will record conditions every 10 to 30 minutes and throughout this whole growing season. So I put them out on May 2nd. I'll be actually grabbing them here in the next couple of weeks and hopefully have a really large data set to work with and kind of see if there's any significant differences across these cars. So this is just kind of helps you visualize what I'm using. They're just about the size of a quarter or a playing card, easy to bury and work with. This is how they're kind of oriented in the cars. So to kind of capture all the different aspects and hopefully be able to like actually get an idea of what the microclimate is within these cars. And so we got 3 on north facing, 3 on south facing, 3 in the trough, and 1 on the ridge. So basically a sensor suite of 10, you could say, at a time. And this will be kind of how we based our sampling. This is a visual picture of when they're actually deployed. Each pink flag, about 1 meter apart or so, has a temperature logger buried in it. And you can see the curvilinear, I should have clarified that. The curvilinear car is probably easy to determine, but that's the one that has kind of the half moon shape on the left there. That's supposed to kind of follow the movement of the sun from east to west throughout the day. And then the linear cars are just straight lines essentially. And this is how we have the temperature loggers buried in them, kind of a random sample, and also capturing different sun angles. We're also doing soil moisture monitoring, since that'll be a good indicator of how well these will retain native species and hopefully provide a decent habitat for gastropods and amphibians. So these are basically, I've been taking soil moisture readings across the same cars and with a handheld Pogo soil moisture meter. And this was done twice a month throughout the whole year. So I'll probably be wrapping up my last survey here in the next couple of weeks. And so about 60 cars per aspect, or 60 readings per car, I should say, and these will be used to analyze later. This is kind of how the same transects have been done every time we visit. And we have sampled the hummocks with soil moisture meter, but unfortunately we didn't actually kind of have the resources to get additional temperature monitors in the ground as quickly as we would have liked this spring. So hopefully in the future we can look at the hummocks a little bit more closely. Another area we're looking at is kind of another kind of control site, you could say. It's actually it actually has mature vegetation on it, and it's up against a dike road with a north facing slope. And this is more just for anecdotal evidence, but the hope here is that it'll kind of be similar to what the cars might experience, and so we could at least maybe get an idea of how those have compared throughout the year, and maybe how the cars might improve as more mature vegetation grows in there and we get more trees and grass growing in these areas. So we also have a mobile weather station deployed in the vicinity. It's about 200 meters away, so it's not impacted by the cars. It records temperature, humidity, wind speed, direction, and rainfall. And the idea here is to be able to compare the readings from this to what we're seeing in the cars, and also maybe be able to see how they respond to like precipitation events. So you can maybe see if they are retaining moisture for longer after a large precipitation event or through the driest portions of the year. So that should be helpful as well for analysis at the end of the year. And we are going to be looking at solar intensity, but that's going to be done basically just with a digital elevation model that was also developed by Brian Heck, just kind of some simple calculations to see how these different slopes really vary, because this solar radiation will have a major impact on not only the temperature, but maybe how hospitable, I guess you could say, these are for amphibians, gastropods, and other sensitive species. So we're going to retrieve the sensors here within the next week or two. We're going to analyze the data this winter and then hopefully have something more substantial to present this spring. So if anybody's interested, you can actually see if these things work. This was kind of just designed with the hopes that it would work, but I don't know of many people that have tried something similar to this. And so our hope that they will be beneficial, but we really want to, hopefully this project and this monitoring will actually see if it's worth the work. So to have a quick sample though, I did dig up a couple of the temperature monitors after a week of the first, month of monitoring, just to make sure they're working really. But it did show that if you average kind of the hottest days of the year, that the temperature monitor in the bottom of the car and the trough was actually about a 0.5 degree C less than that on the top of a ridge. That doesn't really mean much, it's more anecdotal, but it might point to the fact that they are making somewhat of a difference. So. And if we have learned anything so far, it's that weeds, like with anything else, are a big problem, and they're more difficult to deal with with these structures up there. So they're a lot harder to spray and get equipment around. And they've kind of completely taken over and outcompeted the plants that we have planted, at least in a lot of places. And so what we might do in the future is like spend the first year or two just to spray and get this weeds under control after all the soil disturbance, and then maybe wait to plant the native species after that. And then also maybe think about irrigation and protection of these trees, since it's a little harder if you're not working on a flat surface. So that's probably a given, but we've had a lot of trees ripped out by deer and elk, and it's been hard to kind of keep the soil moisture high enough for them to really take off. So that's about it. I just want to say thank you. And if you want more information, you can go to idfg.idaho.gov and bees to bear /bees to bears, or if you just Google bees to bears IDFG, you'll probably see a lot of web pages that come up and can provide some more information if you're interested. So thank you.